Let's get technical. So hello, everyone. My name is Chise. I'm a researcher at Simula and a part-time developer and Forsasys. They're both in Oslo, Norway. And I want to talk to you today about large language models, LLMs, and how we think we can use them for soccer. And shout out to our North American friends who, because of whom I have to call the sport soccer. You know, we like to call it football here in Scandinavia, but thank you, gridiron guys. Yeah. So first, I would be remiss if I did not acknowledge these two things that happened in the past couple of weeks. You might have seen them. They were very high-profile events. One was the spring update from OpenAI, and the other was the Google I/O developer conference, where OpenAI, for example, introduced GPT-4o. They called it for Omni. And Google also pledged or promised upcoming multimodal, large language model-based conversational agents, which means essentially things that are able to understand video, you know, video in, video out, that kind of super fancy stuff. So thank you those guys as well, because they completely messed up my presentation. Okay, so I don't want to go over all of these models here, but I put this figure here from a very nice survey so that you see the sheer scale of the amount of research and development that goes on both in academia and in industry in this field of large language models. And this is just like the barely, I don't know, last 5 years. Yeah? So it's super crowded. There's a plethora of tools, and we are very interested in it. And right now, okay, I don't have a laser pointer, but we're at like the right bottom edge. And those new announcements are not there yet. But the idea is that we are going towards what we call multimodality or multimodal understanding, meaning that we want to have agents, conversational agents, chatbots, or generally large language models, which are able to ingest, interpret, and also generate as output things like video or audio. Let's look at that in more detail. What's a traditional conversational agent or a chatbot? That's something that you maybe type and also get some text as output from, right? So it's text-based. But what we are striving to do, or what in both the industry and academia are striving to do now, is to have, for instance, the possibility to have images, text, of course, audio, video, structured data, maybe, or things like databases or graphs, right? So that it would be possible. I don't know where I'm pointing. So that it would be possible, for instance, to do things like this. Reasoning, you could expect these models to, or these agents to do some reasoning where you give it some data, like some statistics, and then you say, give me what we call the home advantage in soccer. Yeah? So that requires also some sort of understanding of the structured data. Or you could say, here's a video or here's a sequence of frames. Describe to me what's going on here. Yeah, maybe it's a goal, and then you also follow up. So this is visual understanding. You say, I want to understand who scored the goal, or what's he going to do. That example there is pretty stupid, I know. What's he going to do after the goal? Yeah, of course he's going to celebrate. But imagine this being extended further, you know, and with more advanced multimedia as input. Or you could say, I'm super interested in learning about tackles. Yeah? Describe to me what the sliding tackle is, and also show me some fancy examples from the Norwegian Eliteserien. Go find it from, I don't know, this video that I give you, or go find it from the web or somewhere. So this is what we are striving towards as a whole community. And what we do at Simula is actually very much in line with what our colleagues just described. It's automated multimedia production using AI, because we think that this is promising quite a lot. And we have a lot of tasks in mind, such as automatic event detection and classification. This is the scenario or task where you would want to automatically detect, for instance, from the video or live stream or VOD or whatever broadcast, the occurrence of something like, oh, there's a tackle, or there's a goal, or this is the corner kick, or there's a substitution happening. Yeah? So this is exactly the kind of stuff that today we have to manually or semi-manually annotate when we want to prepare something for broadcast. Player detection and tracking is also something that we're very interested in, because you might want to be following a certain player in, on the pitch as the video progresses or during the stream, and then you say, this is the Manchester City game, but you know, I'm here to watch Holland. So forget about the rest and maybe mark him for me and also like get his scenes. Which brings me to the next task. We have this task of highlight clipping, or as our colleagues mentioned, highlight generation, in which you might want to say, I only want the clips of the goals. Yeah, so automatically clip that for me. So I want to give you the video, I want the events being detected, and I want the events being clipped, so to speak, into something like a highlight reel. Because maybe you have a time quota, and then you say, you know, make a summary of the game with a certain personalized priority of types of events. You might want to summarize games. You say, I'm a newspaper editor, and then I actually don't want to write it myself, or I don't have time for it. Just describe to me in this many words how the game was. You might want to crop the videos, which is actually something we spent quite a lot of time on, whereby we started with these, you know, generally horizontal 16:9 broadcast video aspect ratios, but then it was very, very suboptimal to share them on social media or in devices where the viewing, optimal viewing was more portrait or at different aspect ratios. And it was kind of stupid to crop them just by fixing the center, yeah? Because sometimes the action happens over here. You know, the action might be happening anywhere, so what you need to do when you are cropping a video to a certain aspect ratio is actually to have a dynamic cropping window that follows the action. Yeah, and AI was, again, very helpful in this automation, yeah? Another is to automatically select thumbnails. Maybe there's also some personal preferences. And another is, for instance, sharing stuff on social media, which is actually what I think I can come to now. Sorry about this. Which is where actually you can use what I mentioned earlier, the large language models. Yeah? These are the two that we have actually explicitly used large language models with until now, but yeah, we're planning to go ahead and try to see where else we can use them. Now, let's start with this task or product or research that we call Soccer Sum. Here, our goal is to have, for instance, from a highlight clip, let's say this is a goal clip, or it could be a card, or it could be something, or it could be the entire game, if that's what you're interested, to go from this to, let's say, a tweet or a thread of tweets automatically. So I want my model or my tool or my framework to create for me an Instagram post or a tweet or a Facebook post. Yeah? And what we do is we feed some information about this asset to the large language model. Here we have tested with OpenAI's ChatGPT or the API and some game metadata. And we had pipeline like this. I won't go through all of it, but the idea was that we kind of in a hacky way fed the GPT API, the large language model, some information we had derived, still programmatically, but we had pre-derived from the asset. From the video, from the audio, and from the metadata, we fed it some stuff and said, give me a tweet. Yeah, of course, with a better prompt. That's why there's a prompt engineering box there. So you prompt the model with an appropriate prompt and with some input, and then you say, this is the kind of output that I want. Now, what do I mean when I say we fed it some stuff about the asset? Well, we did some object detection, for instance, on the video, where we are detecting the ball, the players, whatever we think is important, and then we're storing this info. We are doing object tracking, for instance, where we are feeding it also the trajectories of specific players. So it's not about detecting a generic player bounding box, but it is about, let's say, this is how Ødegaard was running. Yeah? Or this is how the goalkeeper was moving. So it's a trajectory of a certain player. Then we can also give it things about the pitch itself, right? By automatically detecting these, like the penalty box, the goal box, the corner flag post, and or the referee flags. And then we also feed this information, and then we say, produce for me a tweet, please. And then we saw that this actually worked quite well. I told you that it's kind of hacky, but still it worked quite well, where what I mean is we saw that it was able to understand things like the pitch objects, where it was understanding where the penalty box is, or that it was crowded, you know, that there were people around it, or that it understood the action itself, yeah? And who undertook the action. So these things were kind of understood by the model, language model, and then used for the generation of the tweet, which was kind of cool and our purpose. So we have a demo. Please feel free to visit. We have this on YouTube. And the idea is that we wrap this framework around with the GUI so that people could configure, customize the selection of what do you want to run for object detection, for instance. Do I use a YOLO or do I use something else? What do we use for tracking? Things like that. So we have this video on YouTube. As I said, please feel free to check it out. But as you can see, it is still a bit cumbersome, right? Like, I mean, it's a GUI, but, people have to select a bunch of stuff, and then they also have to know what they're doing, and so you could do better. And the idea there is then to go from this relatively complex thing to this, where now, actually, apparently it is possible, or we are also striving to make it possible with these new types of models, as were announced by these industry giants. We just say, find the metadata from the internet. I'm not feeding it to you, yeah? Or I don't have to be super hacky about the pre-processing of the video, and I just say, here's the video. You do it, yeah? You do the object detection or the player tracking or the whatever. And it is actually possible, or we are coming closer and closer to a stage where these things are possible now with these models, which I said are multimodal, yeah? So we think that this is very cool as a next direction. Another thing we were working on was what we call soccer RAG. RAG is retrieval-augmented generation. And our idea was that the user should be able to pose a natural language query, yeah, and then get some information from data storage, like a database. In our case, it was a SQL database. What we introduced was what we called, for instance, the extractor-validator chain to. Let me also show what we have used. So for the database, we have used this open large data set from a community known as SoccerNet. This is a data set of annotations from, I think, 500 games across 6 or 7 different European leagues from 3 or 4 seasons. And the annotations are for events, like time-stamped event annotations, or bounding boxes, or pitch elements, and stuff like that. So it's a very, very cool data set. And what we did was put it in some sort of a database representation, and then said, can an agent be queried, to fetch information from this database? And for the SQL agent and the extractor, we used LangChain, which then makes it more streamlined to use underlying LLM models. It's more in our specific case, GPT 3.5 and 4 Turbo. And then we had a bunch of, I would call it lame questions, but they were ranging from very basic information, like who played in this league, to more advanced statistics or aggregations, like how many yellow cards or red cards did this player get, or how many times did these two come across, or can you aggregate a certain statistic for this team, but across multiple leagues, things like that. Yeah. So, for example, in the left on the top, you see this one of these simple examples where you're able to ask in natural language, give me all the teams that played in this season. That's basic, right? Or you can say, count all the yellow cards during the season. Or you could also do more advanced filters, because it's just language. And you can also do back and forth, like not one shot, but you can have a dialogue with it. But we also saw that there were some problems, because we're talking about natural language here when we're talking about language models, is that people can say, as you see, Manu for Manchester United. I know that they don't like it. Or you could say Aslan for Galatasaray. Or you could say the Gunners for Arsenal. Or you might actually type it wrong or have a syntax error, right? Or you could, I don't know, you could do all sorts of errors with the prompting, and believe me, we did it. And then we figured out that's why we need something like an extractor to fix the language model's understanding of the natural language queries that the user gives as input. So what we had there was, for instance, the user asking for which of the two teams does blah, blah, blah. But the answer was given in a global manner. Yeah? This is also something that we have experimented with GPT-3 and 4, whereby they have different levels of contextual understanding or semantics understanding. And then we were able to fix it with some sort of cleaning. Other comparisons we did, this is just 2 models compared here, but other comparisons we did included things like this, where we were looking at the execution time for, let's say, 10 questions and 5 rounds of different models. This is over the internet, but same kind of network. And we were seeing that there's also some differences there. Yeah, that's the problem of directly using third-party large language models. But still, ChatGPT is cool. I'm not dissing it, but you see that we also had this diurnal effect or weekly effect of the off-peak, on-peak times. Yeah, during the peak times, of course, your return times were longer. So there's a lot to be looked into there. So we have a demo. This time it's not just a demo video, but it's a live deployment actually on Hugging Face. So if you want to check this out, you can put in your OpenAI API key and then ask our bot some questions. Obviously, it will be limited to whatever information was there in the SoccerNet database or data set that we could put into the database. But I think it's very fun to play around with and super easy to break, but please do so and then, get back to us with your comments. So where do we want to go with this? Where we want to go is, I'm really sorry about the slides, get rid of this database which is just plain statistics or, super basic stuff, but instead put there something like a multimedia gallery. Yeah, because that's the real goal. I want to be able to say, show me all the goals of Messi from this season. And as a source, go look at, I don't know, somewhere. The Saint-Germain website or highlights page. Yeah? Or I want to say, here's the Elite Serie and highlights page. Get me not this player's videos, but a certain events videos or a certain team's videos. Or fetch me, I don't know, something else. Yeah? So the idea is not to have those boring, more structured data, text kind of inputs, but also multimedia as assets. And that's also, I think, where the direction is, where we are all going. Some other stuff to discuss. So the first thing is about proprietary versus open. I know that Sam Altman would tell you OpenAI does not need to have open weights because we're still open in the sense that you can buy access to our models, or there's a chatbot that you can. 4.0 is, for instance, free right now, and you can pay for and then use some other stuff. But that's actually where we respectfully disagree. We not only think that the model weights that you have trained these large language models should or could be open, but also about the methodology of how you trained your large language models and with what kind of data that you trained them with. Yeah. So as researchers, this is very, very important for us. And here I cited the paper which was looking at whether open models were kind of catching up. And we kind of think that they do. And also, we don't really think that it's about just catching up, but it's about doing things in a meaningful manner, like I described, which is sharing also your methodology and also your data sets. The top ones are the open ones, and the bottom ones are the closed ones as of now. This is also a little bit behind. But you see that there's also tremendous interest in the academic community, and it has started, and it is like starting to peak, in developing more open weight models. What open model means is essentially that, as I mentioned, the weights are out there, but we at Simula believe that the community can do even more. And mentioning the sharing of data or the methods by which you train things, I want to emphasize the importance of high-quality, annotated data for training large language models. Here, SoccerNet community, as I mentioned earlier, is a very good example. And they have these challenges every year where they augment their data set with more annotations and organize a challenge around it. And we at Simula are also kind of trying to do something similar where we open data sets of annotations. Like, here's a set of videos with annotations of tackle events, with timestamps. Or here is a, let me see what else. Here is a data set of frames where we have drawn bounding boxes over all players and named them and their kit numbers. Yeah, so if you want to do some jersey number tracking, maybe optical character recognition. Or we have some athlete healthcare data. So multimodal open data sets are really the driving force for our kind of work, which is the academic research work, which is for the benefit of the general public. Yeah, so I really cannot emphasize this enough. We recently had the privilege to also contribute to SoccerNet with what we call the ASR dataset, SoccerNet Echoes, which is essentially a transcription of the game audio commentary. Yeah, transcription and translation. And I know what you must be thinking. It sounds like kind of like a boring data set, right? 500 games, and we transcribe them and translate it to English if they were not in English because they were from 10 languages. But these kind of data sets, especially if they are well curated and human verified, are super, super, super important for large language models. Yeah, so data sets. Another discussion that we have, a debate ongoing, is whether we should have this general artificial intelligence, you know, that's also like the hype right now, versus something that's more specialized. And we kind of, not kind of, but we are very strong proponents of the latter. Yeah, so we think that, especially for things like soccer or sports, actually for each sport, there could be more individualized models and frameworks and systems and applications, precisely because the applications or the use cases are different. Here's an example from the paper of some colleagues where they were actually investigating how a conversational agent, how well a conversational agent would be able to interpret or explain the referee decisions in soccer games. Yeah, because interpretability is also like a very, very important thing that we might be able to achieve if we are training these models in a specific, let's say, domain knowledgeable manner. So this debate, I think, will be ongoing for a while because the big actors would, of course, want to tell you that we have the omni model or we have this, you know, model that now solves all, and if it can teach math, it can also teach you how to tackle. But, you know, I beg to differ, so we're gonna see. Ask me again in like 2 years. So another, I mean, this is related to, I guess, the specialization. OpenAI actually introduced a while back what they call the custom GPTs, and there's a store for download or using or putting your GPTs. But we have looked at these, and these are the ones specifically for soccer. And right now, yeah, it's not in a very good state. It's mainly for betting, or these are chatbots that claim that they are giving you betting advice. The use cases are not very good, and they are also not making use of this multimodal support that I mentioned, because it's slowly being launched, let's say, or put out. But yeah, this is not very good right now. If you look at the GPTs, you can actually go and check. Whatever there is for soccer is not that great. And also you can see how many people have used it, and it's not that many, except for I think 3 or 4 of them. It's like 10 chats that was done with this bot in total. So that's why we are in pursuit of our own soccer chatbot, but of course this is a very, very, very preliminary stage. The goal here is to, as I said, move away from these more traditional or the boring ways of using chatbots to imbuing this kind of multimodal understanding, so that people could upload videos and then get videos. They could upload images and ask questions about it, and they could chat in a manner that they get responses that are kind of demonstrative of some expertise, some domain knowledge. Yeah. So we're working on it, but it's very basic. This is demo is also on YouTube, and we will of course be pursuing this further. But I want to end shortly by saying that, yes, I mentioned to you that these are the things we're working on, and we have used chatbots or large language models explicitly in 2 of them. But all of these use cases, as we have also seen previously, are candidates for large language model enhancements, right? And thinking of the stakeholders or who would benefit from it, you could think about players, both professional and amateur, where they could have customized training assistants. You could think about teams and coaches, where, of course, they could use these agents for training purposes, but also game analysis and game formation or strategy design and things like that. You could think about federations using these, especially within the games, as, for instance, referee support or supporter referees and these kind of automated support mechanisms. You could obviously consider the use cases for broadcasters and streamers, but I want to highlight one that we are actually working on, which is, again, sounding very simple: captioning. Yeah, automatic captioning and translation of live streams. This now we have the possibility to do much, much faster than we were able to do before, and in a wide variety of languages with the advent of the large language models. Fans and researchers, as always, because, you know, I will always be okay with seeing messy clips, better and better messy clips on social media that are like cropped properly. So, of course. And the general public, which is also something our colleagues earlier mentioned. I completely support this notion that the more we support or encourage communities that have less resources, like youth leagues, amateur leagues, or women's soccer, if you think about it, in comparison to men's professional soccer, for instance, you see that there's also some benefit to be gained as an entire society, because you can be helping the communities or groups or institutions that are actually a bit more marginalized in the sense of this multimedia content production and delivery. Yeah? So we could make it more accessible to the public, this wonderful, brilliant sport. And with that, let me announce our YouTube channel once more, and thank you very much for your attention.